Hello guys, we are from Team Vision Math. We are youngsters who want to provide and empower safety and independence for society, especially the visually impaired. Okay, so according to World Health Organization, there are around 2.2 billion people are facing visually disability in worldwide.
Okay, so now how Vision Mate work? So our app combines real-time object detection and object classification as well as object distance measurement and give auditory feedback to the user to receive instant guidance to walk safely and confidently. And the best part is that it all works directly from their smartphone without expensive wearables. And what makes us unique? So, compared to traditional canes or like costly smart glasses, well, our product, we have distance detections which can notify you whether there's an object nearby, like when you're walking forward and then there's a truck in front of you, they will say like, oh, there's a truck in front of you and you should like go left or go right. And then they also, like what I said before, they provide distance awareness and they also give feedback, which is audio and hopefully haptic as well. And then the cost of course, because it's running on our smartphone, so that is more affordable. It's an affordable app. So next. So how is it feasible to the market? So we can see that here is our value proposition canvas. So on the right, you see customer pains and needs, which is safety, affordable, walking safely and avoiding collisions. And then on the left, Vision Mate provides distance detection, audio plus haptic feedback, hopefully, and real-time alerts and inclusion. So we bridge the gap between what they need and what existing solutions fail to provide. So next, so how is it before there's Vision Mate and after Vision Mate? So before, people are struggling to navigate to a new place, like especially visually impaired people. Well, they have like walking stick or like white canes, as we all know, and we also have like Google, AI assistant, but that is too costly. And for walking stick, they only detect like ground object. So after Vision Mate, people, especially those who are visually impaired, they can confidently moving around. So how can we approach our market, our customers? So we have 3 channels here. The first one is NGOs or nonprofits, such as like the World Blind Union. And then we have government and public sector, like the ministries of health, social affairs, or disability services. And next, we also have like community channels. So we approach like blind user associations and local support groups, and accessibility influencers and ambassadors for visually impaired YouTubers or bloggers. Okay. So we have made like a brief of cost structure analysis, in which like for the expense itself, we divide it into 2, which are fixed costs and variable costs, including like the fixed cost is initial development, employee salaries, app or Play Store developer fees, and variable costs like API fees, server and cloud hosting, and then marketing. So this is count by approximately, let's say if we have about 10% users in South Korea. Like before, we have stated that in 2021 there are 25,000 blind people population in South Korea. So if we take like 10% of them, which is about like 25,000 users, the expense will be $2 million. And then we also count like the estimated annual income, which is $3 million, which we have quite a revenue there.
So let me show you how the idea actually works and what we ended up with in the end of the hackathon. So basically, if if I'm the blind person, I'm holding out my smartphone and I'm sending all the data processing happens on the server because this image processing takes a lot of costs and the phone can't handle it on its own, at least most of them. So I'm sending the taken picture of my phone from what's ahead of me to the server, my friend will be at the server. I'll start walking because it takes some time the data to process. I'm getting back the object distances and what objects are ahead of me. Of course, this data will be invalid technically because I've walked, but if I kept my original orientation and the phone can measure my orientation and my speed, then I can actually compensate these values that I got. So I know precisely how close am I to these objects that are ahead of me, and when I'm at those objects, with the same method we can say that before the person hits the object, we can say that please stop. So that was the original idea. So what we ended up doing from this is basically, the problem is that you can't really actually measure, it's very hard to measure distances from a camera, especially if it's Android, because on iOS you have LiDAR sensors which can actually detect the distances. So what we tried is create a depth map with a model that can basically say that on in a static one image with one camera, not two, basically how close are objects to each other, for example these two. So the relative distance is there, but when you want to see how far is from a camera, it's not possible because there is no context. So what we ended up doing is that we use the depth image, and then we basically said that we're gonna limit this image until like the 3 meter area of the user, and then just cut the rest off with just a filter, a color filter, because it's a depth map, and then just we first use YOLO models to detect objects, but we ended up realizing these YOLO models are very good for object detection, but they don't hold a whole word. For example, that whiteboard does not really exist on it, so we just ended up using vision models, LLM vision models, to do the object detection and do the actual distance measurements, which are not very accurate but somewhat usable. But we haven't tested big models, so let's show you the results, what we have.
So basically it gives an audio feedback if, I think the volume is not clear enough. So it gives an audio whether there's like laptop in front of you and what distance.
So basically when you see those black parts, that's where it blocked, it cut off from the very far parts of the image, and just these close parts are actually measured by the object detection with the visual element. So, and there's audio, but it's not.
Yeah. Maybe if we have much more time, we can do a demo directly after this.
So next is the future improvements. So this video will show everyone what our application will look like in the future, more faster detection and I think long distance calculation. So in the future, we plan to reduce real-time detection delay and precision in distance calculation and implement acceleration tracking to warm if the user continue moving toward danger with our stepping aside. So in summary, Versamed is not just an app, it's a step towards safety, independence, and dignity for millions of visual impaired people. We believe technology should empower everyone, and with Versamed, we are making that a reality. So thank you.